Hello everyone. In the fourth module of power generation, transmission and distribution, the second topic is high voltage DC transmission. In a high voltage DC transmission, we are using DC system for power transmission. So high voltage DC system uses DC for power transmission of bulk power over long distances. For long distance power transmission, HVDC links are less expensive and losses are less as compared to AC transmission. It interconnects the network that have different frequencies and characteristics. So one of the main important or advantage of high voltage DC transmission is it does not depends on the frequencies. By using power electronic converters, we can convert the frequency of the system. While we are using an AC system, the frequency is a matter of concern and that causes the system stability. Here, in a high voltage DC transmission, the power generated in AC is converted into DC by using rectifiers, and then it is transferred through a DC line, and at the receiving end, this DC is converted to AC by using inverters or power electronic converters, and it is fed to the feeder. This is the basic diagram of a HVDC transmission system. Usually a back-to-back converter arrangement is used, and along with the converter there will be transformers, high voltage DC transformers for increasing the voltage level. The electric power is generated as AC and is stepped up to high voltage by sending a transformer. AC power at high voltage is fed to the rectifier and is converted to AC to DC. The transmission of electric power is carried in high DC voltage. At the receiving end, DC is again converted back to AC with the help of inverters. The AC supply is stepped down to low voltage by receiving a transformer for the distribution. While we are using DC system, the power equation governing the system is Vs into Vs minus VR by R. This is only governed by Ohm's law. V into I is change in voltage by resistance, Vs minus VR by R. But if it is AC system, power depends on reactance X and also phase displacement angle theta. Equation is Vs VR by X sine theta, or writing it as delta. We used to write it as delta. Then we can have a comparison of DC and AC transmission system. In DC transmission system, for some years past, the transmission of electrical power by DC has been receiving the active consideration of engineers due to these advantages. Its first advantage is it requires only 2 conductors as compared to 3 for AC transmission system. And also there is no inductance, capacitance, phase displacement and also surge problems. Due to the absence of inductance, the voltage drop in the DC transmission line is very much less than AC line for the same load and the sending end voltage. For this reason, DC transmission line has better voltage regulation. Voltage regulation is change in voltage. Voltage drop is less, so the change in voltage is less. And there is no skin effect. As we all know, in AC system, the current mainly concentrated in the skin or the surface of the conductor due to the skin effect. In DC system, there is no problem with skin effect as the frequency is zero. Therefore, entire cross section of the line conductor can be effectively utilized. And also for same working voltage, the potential stress on the insulation is less in case of DC system than in case of AC system. So, DC line requires less insulation. The DC line has less corona loss and reduced interference with communication circuits as the frequency is 0. Then the high voltage DC transmission is free from dielectric losses, particularly in case of cables. In DC transmission, there is no stability problems and synchronizing difficulties as there is no issues with frequency or phase displacement. The disadvantages are electric power cannot be generated at high voltage due to commutation problems. We know that in DC generators, it requires split ring or commutator. There will be sparking problems if it used for high voltages. So power generation is more easy in AC by using alternators. The DC voltage cannot be stepped up for transmission of power at high voltages. We know that the transformer will not work at DC. So stepping up and stepping down of DC voltage is difficult, but now the power converters are available for increasing the voltage level, but it will not be economical at high voltages. The DC switches and circuit breakers have their own limitation. Nowadays, all the switches and circuit breakers are mainly designed for AC systems. Then we have a look at it AC transmission system. That is the commonly used one. The main advantage is power can be generated at high voltages. Maintenance of AC substations is easy and cheaper compared to DC. The AC voltage can be stepped up or stepped down by transformers with ease and efficiency. This permits to transmit power at high voltages and distribute it at safe potential. The disadvantages are an AC line requires more copper than DC line. The construction of AC transmission line is more complicated than DC transmission line because it requires more number of conductors, and also we have to carry the equal distribution of inductance among the conductors. Due to skin effect AC system, in the AC system, effective resistance of the line is increased. AC resistance will be more than the DC resistance. An AC line has capacitance, therefore there is a continuous loss of power due to charging current even when the line is open. Due to the capacitance, there is loss of power. Now we can have a look at different types of HVDC transmission system. The classification of HVDC system depends upon the arrangement of pole and earth return. The main types are monopolar link, bipolar link, and homopolar link. First one is monopolar link. A monopolar link has only one conductor with ground or C as the return path. There will be only one conductor and ground or C is used as the return path. Generally, the conductor has negative polarity with respect to ground. It is mainly used in submarine cable transmission. Here it shows the figure of monopolar structure. Here it is used in submarine cable transmission system. Here AC is generated, rectified, and it is transmitted through a single conductor, and here it is inverted to AC and distributed. Here the return path is water. So there is only one cable required. Here it shows the circuit diagram. The return path can be earth or water. Main advantages are corona effect in DC line is less. Less conductor material is required as the earth or water is the return path. Only one conductor is required. So less insulation cost. Next is bipolar links. Bipolar links have two conductors, one at the positive potential and other at the negative potential with respect to ground. At each terminal, two identical sets of converters are connected in series. There are two converters connected in series at both sides. Midpoint is earthed. Main advantages are power transmission capacity is doubled when compared to monopolar links. And also, when fault occurs in one conductor, the power can be transmitted through other conductor. The disadvantages are terminal equipment cost is high compared to monopolar. More conductor material is required compared to monopolar, and corona loss is high compared to monopolar. Then next is homopolar links. It has two or more conductors all having same polarity. Here in bipolar links, one conductor is having positive polarity and other conductor is having negative polarity. But in homopolar links, there will be more than one conductor, two or more conductors having same polarity, and the ground is used as the return path. So here both conductors have same polarity, same current direction, and the ground is used as the return path. The corona effect is less in negative polarity conductors. So if all conductors are with negative polarity, corona effect can be reduced. Less conductor material is required because ground is used as the return path. For a particular power, less conductor material is required as the ground is used as return path. We can avoid power interruption due to the fault by transmitting power through other conductor. If one fault occurs in one conductor, power can be transferred to other conductor. And reliability is high and insulation costs are low. Then disadvantages: ground return path causes corrosion of the buried metallic structure. Since the ground is used as the return path, it may cause corrosion of the metallic structure. Then causes disturbance in underground communication cables. If underground communication cables are used, it may cause disturbance in the communication cables. These are the types of HVDC transmission system. We have seen which are the what is HVDC transmission system and what are the advantages of HVDC transmission system or DC transmission system, and different types of HVDC transmission system. Thank you.